Imagine standing at the edge of everything that exists. You look beyond the farthest galaxy ever discovered, beyond trillions upon trillions of stars, beyond black holes, nebulae, and every corner of the known universe. Then a simple question enters your mind. What comes after that? Most people would naturally say more space. But then another question appears. What comes after that? And after that? And after that? Very quickly, the human mind reaches a place where ordinary thinking begins to fail. We find ourselves face to face with one of the deepest mysteries in existence: infinity. For thousands of years, infinity has fascinated humanity. Philosophers, mathematicians, scientists, and religious thinkers have all struggled to understand whether infinity is something real or simply an idea created by the human mind. When people hear the name Albert Einstein, they usually think about relativity, black holes, or the famous equation relating mass and energy. What many people do not realize is that Einstein spent much of his life thinking about questions that were closely connected to infinity. Questions about the size of the universe, the nature of space, the beginning of time, and the limits of reality itself. His views on infinity were not simple. He did not completely accept it, and he did not completely reject it. Instead, Einstein approached infinity with caution, curiosity, and a deep respect for evidence. To understand what Einstein believed, we first need to understand why infinity is such a strange concept. Long before Einstein was born, ancient thinkers were already debating whether infinity could truly exist. Some argued that everything must have boundaries. Others believed that space and time could continue forever. One famous philosopher created a puzzle that still surprises people today. Imagine walking across a room. Before reaching the other side, you must first travel half the distance. Then you must travel half of the remaining distance, then half again, and half again. This process can continue forever. The philosopher argued that because there are infinitely many halves, you should never actually reach the other side of the room. Of course, we all know that people walk across rooms every day, yet the puzzle revealed something important. Infinity behaves in ways that seem to challenge common sense. For centuries, infinity remained mostly a philosophical mystery. Then mathematics entered the picture. During the 19th century, mathematicians began studying infinity more seriously. They discovered something that seemed impossible. Not all infinities are the same size. There are infinitely many counting numbers. 1, 2, 3, 4, and so on forever. But mathematicians showed that there are even more decimal numbers than counting numbers. In a strange way, one infinity could be larger than another infinity. These discoveries shocked the scientific world. Einstein was familiar with these ideas and respected the mathematics behind them. However, he was interested in a different question. Mathematics can describe infinite things on paper, but does an actual infinity exist in the physical universe? That question would become one of the most important issues in modern science. When Einstein began his scientific career, most scientists believed the universe had always existed and would always exist. The common view was that the cosmos was eternal and unchanging. Then Einstein developed his theory of general relativity. This revolutionary theory transformed humanity's understanding of gravity, space, and time. Before Einstein, space was often imagined as an empty stage where events simply happened. Einstein showed that space itself could bend, stretch, and curve. Time was not separate from space. Together they formed a single structure called space-time. Mass and energy could warp this space-time, creating what we experience as gravity. The implications were astonishing. When Einstein examined his own equations, he found something unexpected. The universe should not remain perfectly still. It should either expand or contract. This result bothered him. At the time, Einstein preferred the idea of a stable universe that never changed. An expanding universe seemed strange and unsettling. So he made a modification to his equations. He introduced something called the cosmological constant. This additional factor balanced gravity and allowed the universe to remain static. For a while, Einstein believed he had solved the problem. But nature had other plans. A few years later, astronomers began observing distant galaxies. They discovered that those galaxies were moving away from us. The universe was expanding. The very thing Einstein had tried to avoid was actually happening. His original equations had been right from the beginning. This experience taught Einstein an important lesson. Reality does not care about human preferences. The universe is under no obligation to match what seems comfortable or intuitive. As scientists continued exploring the implications of relativity, Einstein began considering one of the biggest questions of all. Is the universe infinite? Most people assume there are only two possibilities. Either the universe is finite and has an edge, or the universe is infinite and stretches forever. Einstein proposed a third possibility. The universe could be finite without having an edge. At first, this sounds impossible. How can something have a limited size if it has no boundary? The answer comes from curved geometry. Imagine an ant living on the surface of a globe. The ant can walk in any direction and never encounter an edge. There is no place where the surface suddenly ends. Yet the surface area of the globe is finite. The ant's world is limited in size but has no boundary. Einstein suggested that the universe itself might work in a similar way. Space could be curved. If someone traveled far enough in one direction, they might eventually return to their starting point. In this picture, the universe would not be infinite. It would simply be finite and unbounded. This idea was revolutionary because it showed that infinity was not necessary to eliminate edges. For Einstein, this possibility was appealing. He often preferred models that avoided actual infinities. The reason was simple. Throughout physics, infinities often appeared when theories stopped working properly. Whenever calculations produced infinite quantities, scientists became suspicious. Imagine calculating the temperature of something and getting an answer of infinity, or calculating an infinite amount of energy. Such results usually suggest that a theory is incomplete. Einstein noticed this pattern repeatedly. Certain solutions to general relativity predicted regions where density became infinite and space-time curvature became infinite. Today, we call these regions singularities. Black holes provide a famous example. According to classical relativity, matter collapsing inside a black hole may eventually reach a point of infinite density. Einstein was uncomfortable with this idea, not because he thought the mathematics was wrong, but because infinities often signal that deeper physics remains undiscovered. Many modern physicists share this view. They suspect that future theories combining relativity and quantum mechanics will remove these infinities and replace them with something more physically meaningful. Einstein spent many years searching for a unified theory that could explain all forces of nature within a single framework. He hoped such a theory would reveal a deeper level of reality and eliminate many of the infinities that appeared in existing equations. Although he never completed that goal, his efforts influenced generations of scientists. Infinity also appeared in Einstein's thinking about time. Did time have a beginning? Did it stretch endlessly into the past? Would it continue forever into the future? These questions became increasingly important as evidence for an expanding universe accumulated. Eventually, scientists developed what became known as the Big Bang theory. According to this idea, the universe began in an extremely hot and dense state approximately 13.8 billion years ago. Interestingly, Einstein was initially skeptical of some aspects of this picture. Like many scientists of his era, he found it difficult to imagine a universe with a definite beginning. Yet observations continued supporting the idea of cosmic evolution. Once again, evidence guided science forward. Even today, the question remains open. Did time truly begin with the Big Bang? Or was there something before it? No one knows for certain. Einstein's theories opened the door to these questions, but they did not provide all the answers. Another fascinating consequence of Einstein's work involves the observable universe. Even if the universe is infinite, we cannot see all of it. Light travels at a finite speed. Because the universe has existed for a finite amount of time, there are limits to how far light could have traveled since the beginning of cosmic history. As a result, there is a cosmic horizon. Beyond that horizon lie regions we cannot observe. Those regions may continue forever, or they may not. Current observations cannot tell us. This means that some aspects of infinity may remain permanently hidden from human view. We can investigate them through mathematics and theory, but direct observation may never be possible. Today, more than a century after Einstein transformed physics, scientists still debate the ultimate nature of infinity. Measurements suggest that the universe appears remarkably flat on large scales. A perfectly flat universe could potentially be infinite. However, it could also be finite but so enormous that its curvature is too small for us to detect. The mystery remains unresolved. Modern theories have introduced even more extraordinary possibilities. Some suggest the existence of multiple universes. Others describe endlessly expanding cosmic regions where new universes continually emerge. These ideas push the concept of infinity into territory even stranger than Einstein could have imagined. Yet all of them rest upon foundations that Einstein helped build. So what did Einstein ultimately believe about infinity? The answer is subtle. He accepted infinity as a powerful mathematical concept. He acknowledged that reality might contain infinite aspects, but he remained cautious about treating physical infinities as unquestionable facts. Whenever infinity appeared in nature, Einstein wanted to know whether it represented something real or whether it revealed a gap in human understanding. He often favored models of the universe that were finite, yet without boundaries. Most importantly, he believed that questions about infinity should be answered through observation, evidence, and reason rather than pure speculation. For Einstein, science was not about defending personal beliefs. It was about discovering how reality actually works. Perhaps that is the most important lesson he left behind. Infinity reminds us that human knowledge has limits. Our brains evolved to navigate everyday life on a small planet orbiting an ordinary star. They were never designed to comprehend endless space, eternal time, or realities beyond imagination. Yet Einstein showed that curiosity can carry us surprisingly far. By questioning assumptions, following evidence, and remaining open to unexpected truths, humanity can continue exploring mysteries that once seemed impossible to understand. The question of infinity remains unanswered. The universe may be finite, the universe may be infinite, or reality may be stranger than either possibility. But thanks to Einstein, we now possess powerful tools for investigating those mysteries. And perhaps that is the greatest achievement of all. Not that he solved infinity, but that he taught us how to keep searching for the answer.